Okay, rate times time equals distance. That's what this problem is about. A bus and a train left the same town at 8 a.m., both heading south. By noon, the bus was 100 miles behind the train. If the train's speed is twice that of the bus, how far did each travel by noon? Okay, there's a lot of information in this problem, and we have to figure out a way to organize it. These types of problems are all different. And the main difference in our book is what they tell us about the distances. So let's deal with that first. Let's write something down so that we know what's going on with the distances. So what do we know about the distances? There's a train and a bus. The distance of the train is something. We don't know what it is. They didn't tell us. The distance of the bus is also something, but they did tell us something about it. That is 100 miles behind the train. So the distance of the bus is less than that of the train by 100 miles. So this is the distance situation, and we can use this picture to write an equation about the distances. We can say that the distance of the train is equal to the distance of the bus plus another 100 miles, because the bus has not gone as far as the train, so you have to add 100 miles to the bus's distance to get the distance of the train. All right, we have said what we needed to say about the distances. Now we're going to fill in all the other information using a chart to organize it. So here we have a chart, we have a train, we have a bus. Let's read the problem and see what they tell us. They tell us that they left at the same time, 8 a.m., and by noon is what we're talking about. What's happening at noon? That's when the bus is 100 miles behind the train. So if we started at 8 a.m. and it's now noon, that's 4 hours. The length of time the train has been going is 4 hours. The length of the time the bus has been going is 4 hours. Now they tell us that if the train's speed is twice that of the bus. So we don't know either one of their rates, but we do know that if the rate of the bus, say, is R, we'll call it, then the rate of the train is 2 times that. The train is faster than the bus. That makes sense because the bus is behind. Now we have filled in a rate and time for each one, and now I'm going to use the equation rate times time equals distance to fill in the distance. 2R times 4 is 8R. 4 times R is 4R. I'm going to take what is in the distance box, and I'm going to go back to the equation I wrote at the beginning of the problem, and I'm just going to substitute in for d sub t the distance of the train, and for d sub b, I'm going to substitute in the distance of the bus. So distance of the train is 8R. The distance of the bus is 4R, and then plus 100. And now I'm going to solve that equation for R. So if I'll just rewrite it. I will subtract 4R on both sides. And I will have 4R equals 100. So R equals 25. Now, what does R stand for? We can't forget what it means. It means, here we go, right in the box is R is the rate of the bus. So that is miles per hour. Is that what the problem is asking for? No. It says how far did each travel by noon? So how far did they each travel? Well, the rate of the bus will help me figure out how far it traveled because I know the distance of the bus is 4 times the rate. So the distance of the bus is 4 times 25 or 100 miles. To find the distance of the train, I will need 8R because that is what is in my table for the distance of the train. So R is 25, so 8 times 25 is 200 miles. All right, so we got what we were trying to find. Okay, this is another problem about rate times time equals distance, and we're going to do it the same way we did the last one by looking at what they're telling us about the distance first. Jamie and Alex are racing toward each other on a road trip adventure. They start from the 2 different cities that are 300 miles apart, both leaving at the same time to meet up. Alex's car cruises along at 45 miles per hour, while Jamie's goes a bit faster at 55 miles per hour. How long will it take Alex and Jamie to meet on the road? So what do we know about the distances? We know that they are starting at two different places and heading toward each other, and that they start out at 300 miles apart. Okay, so Jamie is going to go some amount of the way from where he's coming from, and Alex is going to start from where he's coming from, and they're going to meet somewhere between. And so you can see that their distances will add up to 300 miles. So our equation we can write is that the distance of Jamie plus the distance of Alex is 300 miles. So now we know our situation with the distances, and we are going to fill in our chart again with rate times time equals distance. We're going to figure out the rates and the times, and we're going to fill in the distances using the equation rate times time equals distance. Okay, so Alex's car is going at 45 miles per hour. We will fill that in right here for Alex's rate. While Jamie's goes a bit faster at 55 miles per hour, so we will fill in his rate as 55. How long will it take Alex and Jamie to meet on the road? All right, we don't know their times, but their times are the same. They both leave at the same time and they meet at the same time. So their times are equal, but we don't know what they are, so we can just call them the same letter, and I'm going to use the letter T. All right, now instead of trying to do anything about the distance, I'm just going to fill in what's in my chart. Rate times time. Rate times time is the distance. Rate times time is the distance. Now I will use my equation that I made at the beginning of this problem to substitute these values into that equation. D sub j plus d sub a equals 300. So d sub j is 55t, so I'll put that in. D sub a is 45t, I'll put that in. And that is equal to 300. So 100t is equal to 300. So t is equal to 3, and this is time, and that would be hours. Is that what the question is asking for? Yes, it is. How long will it take? 3 hours. Okay, while making her famous buttercream frosting, Marcia accidentally put in 2 3/4 times as much icing sugar as the recipe called for. If she put in 550 grams of icing sugar, how many grams were actually called for in the recipe? Okay, so the thing we're looking to find out is how many grams were in the recipe. So I'm going to call that R. So the number of grams of sugar called for in the recipe. I'm going to call that R. All right, so the problem tells me that she put in 2 3/4 times R into the recipe, and that she put in 550 grams. So that is 550 grams. We don't want to work with a mixed number, so we're just going to change it to an improper fraction. 4 times 2 is 8, plus 3 is 11. So that's 11/4 R equals 550. If we multiply both sides by 4/11, we will solve for R. We know 11 goes into 550 50 times. So 50 times 4 is going to be 200 grams. 20% of the ice melted. If 680 grams of ice remained, how many grams melted? All right, so we have a pile of ice. Some of it melted and some of it remained. So I'm going to start out by calling the ice, all of it, before anything happened. That amount of ice is going to be I. So that's the total ice in the problem. So the problem, what does it say? 20% of the ice. So 20% of means multiply the ice. That's how much melted. If 20% of the ice melted, the other 80% did not melt. So 80% of the ice remained. Okay, so what I have done right now is I have just written down everything I know about this ice as far as what melted, what didn't, what was there to start with, etc. All right, now I can start filling in the exact information they give me. The only thing they really say is that 680 grams of ice remained. So that is going to work in that third equation I wrote. 80%, which is 0.8, times however much ice there was to begin with, is how much remained, which is 680 grams. Now I can divide both sides by 0.8. So 680 divided by 0.8, 850 grams of ice. That's not the amount of ice that melted. That's the amount of ice there was to begin with, because that's what I called I. That's what I want it to be. So the problem asks me how many grams melted. So I've got the amount that remained. I have the amount that we started with. So if I want to figure out how much melted, I will subtract the amount of ice I started with minus the amount of ice that was there after the melting occurred. So I'm going to subtract, and I'm going to get 170 grams for the amount of ice that melted. Okay, we want to simplify these expressions completely. So we have -8 in parentheses raised to the -2/3 power. And so we know that a negative exponent tells me to take the base, which is this, and take the reciprocal of it. So 1 over -8 in parentheses. And now I can change the sign on the exponent to +2/3. Now I'm going to do what I need to do to the number -8. I'm going to take the cube root. That's what the bottom number of the exponent tells me to do. So 1 over the cube root of -8. And then the top number, 2, tells me to square that. So the cube root of -8. Cube root means what number can I multiply by itself 3 times to get -8, and that number is -2. -2 times -2 times -2, that's 4 times -2, that is -8. So the cube root of -8 is -2, so -2 is what I get for that, and then I'm supposed to square that. -2 times -2 is 4, so this is 1/4. Part B, same kind of situation, except now the base is in the denominator of the fraction and there are no parentheses. So when I see this -2/3 on my exponent, that tells me to take the reciprocal of the base and change the sign to +2/3. Since the base is already in the denominator, instead of writing 1 over -8 to the +2/3, I can write it as just -8 to the +2/3. I'm going to move it from the denominator up into the numerator, and then I can change the sign on the exponent, because moving something from the denominator into the numerator is just like taking the reciprocal of it. So -8 to the +2/3 power. Now remember, when there are no parentheses, I can just ignore the negative sign for a minute. So I'm going to put it in a box and pretend that it doesn't exist. And I'm just going to work with the 8 to the 2/3 power. So I'm going to take 8, and I'm going to take the cube root of that, and then I'm going to square it. So cube root of 8, cube root of +8 is +2, because 2 times 2 times 2 is 8. So I'm going to square that and get 4. Now I have to remember to go back and get that negative sign and stick it back on. So when there are no parentheses, the negative sign can be ignored and then stuck back on at the end. I'm going to be very careful as I do this problem to change all the numbers to scientific notation, and I want to make sure that there is only one digit to the left of the decimal. What I mean by that is I want to make sure that when I am done, my term at the beginning of the expression looks like something like 1.35 or 2.47 or 9.21. All of these numbers I just wrote have one digit on the left side of the decimal. I don't want something like 23.7 or 13.5. No, I don't want that. I don't want two digits to the left of the decimal. I just want one digit to the left of the decimal point. So whenever you're doing scientific notation, make sure that your final answer has only one digit to the left of the decimal point. So I'm going to start out by writing every single number in scientific notation. 50 can be written as 5 times 10 to the first power. Then I also have a 10 to the negative 10. Now I have the number 0.000024. I know that this number is going to have a negative exponent on the 10 because it's a tiny number. So whenever you have a tiny number like that, where you've got lots and lots of zeros to the right of the decimal, you know that your exponent on 10 is going to be a negative number. I was just saying that I only want one digit to the left of the decimal point. So I know I'm going to write this as 2.4 times 10 to the something. And since I don't really want 2.4, like I just wrote, okay, I want 0.000024. So in order to tell myself or to tell anyone that this is not really 2.4, it's really this, I'm going to put an exponent on 10 that tells you to move this decimal over this many spaces, which is 6. So negative 6. 2.4 times 10 to the negative 6. That tells me take 2.4 and move the decimal 6 places to the left. And that is what I want because that's what I'm trying to represent. Okay, on the bottom, I've got a big number, so I know that my exponent on 10 is going to be positive, and I have 6 zeros, and so that is 8 times 10 to the 6th power. Now I'm going to multiply my numbers. On top, I've got 5 times 2.4, which is 12. Now I'm going to add the exponents on the tens because they are like bases. 1 minus 10 is negative 9, minus 6 is negative 15. And on the bottom, I still have 8 times 10 to the 6th power. 12 divided by 8 is 1.5. So I can do that division. Now I'm going to subtract the exponents on my tens. So 10 to the negative 15 minus 6. Because when you divide like bases, you can subtract the exponents. So 1.5 times 10 to the negative 21. That would be the final answer. Okay, we want to multiply this and we want to simplify it completely. All right, so the first thing I want to do is just go ahead and use the distributive property so that I can get that part out of the way and I don't have to worry about it anymore. So this times this, that's 3 times the square root of 50 times 2 square root of 28. Now I'm going to put my minus sign and I'm going to multiply by this. Now I'm going to write each radical as a product of primes. So if I'm not sure what those would be, I can take 50 and start breaking it down. 50 is 2 times 25, and 25 can be written as 5 times 5. So those are all primes. 2 times 5 times 5 equals 50. So I'm going to rewrite that radical as the square root of 2 times the square root of 5 times the square root of 5. And then I've got 2 times the square root of 28. So I'm going to write 28 as primes. So factor out a 2, and I'll be left with a 14. And that can be written as 2 times 7. So 28 is 2 times 2 times 7. So I'm going to write that radical in that way. So 2, I already have a 2 there. And then square root of 2 times square root of 2 times square root of 7. I'm going to put my minus sign. Make sure you make your minus sign long enough so that it doesn't look like a multiplication sign. All right, another 3 square root of 50 here. I'm going to write it exactly the way I wrote it on the left side. So 3 times the square root of 2 times the square root of 5 times the square root of 5. And then I also have that square root of 6 there, which I'm going to write as the square root of 2 times the square root of 3. Now, remember, because of the definition of square root, the square root of 5 times the square root of 5 is 5. So I'm going to rewrite this as 3 times the square root of 2 times 5, because the square root of 5 times the square root of 5 is 5. Then I've got a 2 here. The square root of 2 times the square root of 2 is 2. So I'm going to put 2 there. And then I've still got this square root of 7 that's just sitting there. Over here, I've got the square root of 5 times the square root of 5 there also. So I've got 3 times the square root of 2. Square root of 5 times the square root of 5 is 5. So I'm just going to put a 5. And then I've got the square root of 2, square root of 3. So now I'm just going to line everything up so that I can multiply the numbers that are not under a square root and multiply the square roots together. 3 times 5 times 2 times 2 times the square root of 2 times the square root of 7. And then over here, I've got 3 times 5 times the square root of 2, square root of 2, square root of 3. So on the left, I've got 15 times 4, that's 60. And square root of 2 times square root of 7 is just the square root of 14. That can't be reduced any further. And then I've got 3 times 5, which is 15. And then I've got square root of 2 times square root of 2, which is 2. And then I still have that last square root of 3 sitting there. So finally, I'm just going to end up with 60 times the square root of 14 minus 30 times the square root of 3. Okay, we want to find the equation of the line that passes through the points -4, -5, and 4, -1. What we need to remember is that whenever we're finding the equation of a line, we are always just looking for two things: the slope, which we call m, so that's the rise over the run. And what that means is how far up do you go and how far over do you go to get from point to point on the line. And then we are also looking for b, the y-intercept. Where does this graph cross the y-axis? Once we have those two values, we can write the equation, because the equation is y equals mx plus b. So in our final answer, there will always be a y right here. There will always be an x right there. And there will be my m and my b, which I have found by the following process. So the first thing I'm going to do is graph the 2 points. So -4, -5, go over left -4 and down 5. And there's that point. And then 4, -1, you go over 4 to the right and down 1, and that's right there. And to draw the line, you just go through those 2 points. Now, to find the slope, we see how far up you have to go, which is 4, and how far over you have to go, that's 8, to get from one point to the other point. That's your slope. Rise is 4, run is 8. So m equals 4 over 8, which is 1/2. Now I'm going to write my equation. Y equals m, which we know is 1/2, x plus b. Now this is what my final answer is going to look like, except I need to find b. So go back and use the equation that you just wrote, y equals 1/2 x plus b, and put in one of these points into that equation for x and y. All right, so I'm going to use this one because it looks a little bit easier. So y is -1. I'm going to put that there. 1/2, and then x for that point is 4, and then plus b. Now I need to solve for b. 1/2 times 4 is 2, plus b, subtract 2 on both sides, and you get that b is -3. So now I have my m, which is 1/2, I have my b, which is -3, and I can now go ahead and rewrite the equation again with the m and the b that I just figured out. So y equals 1/2 x minus 3 is going to be the equation of that line. Okay, we want to simplify this fraction. The problem with this fraction is that it has fractions in it. It has 4 little fractions in it. So we want to get rid of those and make it just so that there's something on the top in the numerator and something on the bottom, just one thing, not a fraction. Okay, so what we have to do then is we have to get common denominators for all these little fractions. So you've got all these little denominators and you want a common denominator. So it has to have all those factors in it. We have x squared, we have z squared, we have 1. 1 can be written as 1 over 1, so the denominator of that is 1. And then we have x squared, z squared. So our common denominator has to be x squared, z squared. So we have to multiply each fraction by something over something that will give us that denominator. So the first fraction has a denominator x squared, so it doesn't have the z squared. So we're going to have to multiply it by z squared over z squared. The second fraction has the z squared in the denominator, but it doesn't have the x squared. So we're going to have to multiply by x squared over x squared. The 1 doesn't have the x squared or the z squared. So we can think of 1 as 1 over 1, and we're going to have to multiply the top of that by x squared z squared, and the bottom also by x squared z squared. And this little fraction on the right has both already, so I don't need to do anything to those. So I'm going to go ahead and erase this common denominator so I can move on to what I'm going to do next, which is to go ahead and do the addition. So on top, I'm going to add those two fractions. When you add fractions, you add the numerators. So 3acz squared plus 2x squared. And then the denominator is just x squared z squared. You don't add the denominators. You just leave the denominator the way it is. On the bottom, we have x squared z squared minus 4. And that is all over x squared z squared. So now I have two fractions. The top fraction is being divided by the bottom fraction. So I have 3acz squared plus 2x squared over x squared z squared divided by, that's what this line means, divided by x squared z squared minus 4 over x squared z squared. So when we divide two fractions, we can take the first fraction, so this is the fraction from the numerator, and we can multiply it by the reciprocal of the other fraction. So x squared z squared is on top over x squared z squared minus 4. Now I am multiplying these two fractions together, and so the x squared z squared cancels on the bottom, and it cancels on the top. So now all I have left on top is 3acz squared plus 2x squared. And on the bottom, I just have x squared z squared minus 4. There is no way to reduce this. There is not a common factor here. 3acz squared plus 2x squared, and then we have on the bottom x squared z squared minus 4. They do not have a common factor that they all share. You can't do any canceling at this point. Okay, we want to divide these two polynomial fractions. And to do that, we're going to do a lot of factoring of trinomials. And so first thing we're going to do is change the division problem to a multiplication problem, because when you have a fraction divided by another fraction, you can do the fraction times the reciprocal of the other fraction. So we've got the first fraction stays the same, second fraction flips upside down, and now we're going to factor. To factor this first one, remember, we put two sets of parentheses. We want it so that the first two things we multiply will give us x squared. So that's going to be x and x. We're looking for two numbers whose product is -6 and whose sum is -5. 1 times 6 or 2 times 3. That's the only two ways you can write 6 as a product. 2 and 3 won't work, because if you put -2 and -3 to get -5, that's going to give you a +6 as a product, because -2 times -3 is +6, and we want -6, so that doesn't work. we need to use 6 and 1. So 6 and 1, I want that to add up to -5, so I need a -6 and a +1. Now I have this trinomial right here, and same thing. I'm going to use x at the beginning for both to get x squared. I want two numbers that multiply together to give me 20, -20, and add up to -1. Well, that's going to be 1 times 20, or 2 times 10, or 4 times 5. Those are all the ways to write 20. And so if I try to do 1 and 20, that's definitely not going to, there's no way I can make that add up to -1. If I use 2 and 10, there's still no way I can make that add up to -1 that I need right here. So 4 and 5 are what I need. So 4 and 5, I want to put the signs on these so that they add up to -1. So I need to make the 5 negative and the 4 positive. That will add up to -1 and will multiply together to give me -20. On this one, I'm going to put x and x. And then I'm looking for two numbers that multiply together to give me -3, and that will add up to -2. Well, the only two numbers that multiply together to give me 3 are going to be 3 and 1. It's prime. And so I want to make the signs so that I can make the 3 and the 1 add up to -2. And that would happen if I make the 3 negative and the 1 positive, because -3 plus 1 is -2, and -3 times 1 is -3. That's exactly what I wanted. Over here, I'm going to put the x first, and then I need two numbers that multiply together to give me 30 and add up to -11. Well, for 30, you can have 30 times 1, you can have 2 times 15, you can have 3 times 10, and you can have 5 times 6. Those are the only choices to multiply together to get you 30. But you need the two numbers to add up to 11. That's not going to work. That's not going to work. That's not going to work. 5 and 6 do add up to 11. I want it to be -11, so I'm going to make them both negative, and that's okay because I want +30, and -5 times -6 is +30, so that works. All right, so I have factored all the trinomials, and now I can, since this is all multiplication, x minus 6 times x plus 1 times x plus 4 times x minus 5 over x minus 3 times x plus 1 times x minus 5 times x minus 6. Those are all factors. I can cancel factors in division. So x minus 6 can cancel, x plus 1 cancels, x minus 5 can cancel, and I end up with x plus 4 over x minus 3. All right, again, I have a fraction. I want to cancel a common factor. All of these numbers here, 12x squared, 3x, 3x, they all have a common factor of 3x. So I'm going to factor out 3x. If I take out the 3x for the first term, I'm left with a 4, because 4 times 3 is 12, and an x factor, because x times x is x squared. For the 3x, I factored out a 3x, so all I have left there is 1, because I want this to multiply together to give me 12x squared minus 3x. I don't want to change anything, and so that is what I just did. It still equals 12x squared minus 3x, but I've just changed the way it looks. This is 12x squared. This is 3x, so it's 12x squared minus 3x, but I have factored it. Now, on the bottom, I still have 3x, and that's all that's there. We can think of that as 3x times 1. Well, the factor of 3x is gone, and I'm just left with 4x minus 1 over 1, which is just 4x minus 1. All right, I want to factor this completely. First of all, I can see that I have a factor of 3 in all three of those terms, because 3 goes into 30, it goes into 3 and 75. So I can take out a 3. I can see that I have a factor of x because I have x squared, x cubed, and x. So I can factor out an x. I have a factor of a in all three. So what's left? For the first term, I have a factor of 10. 10 times 3 is what gives me 30. I have a factor of x because I only have one factor of x here, and there are two factors of x there, so just an x. And the a I have already taken out, so it's gone. All right, moving on to the next term, minus The 3 I already factored. The x, I need 2 more factors of x to make that x cubed. And the a is factored out, so I don't need to write that. Now I've got 75. 3 gives me 75 25 times, so I need that 25. I've got the a, I've got the x, so I don't need anything else. Now, I'm not done because I need to factor this completely. So this trinomial right here can also be factored. It's not in order right now, and it has some negative signs where I don't want them to be. So I'm going to rewrite it, first of all, in the correct order. So the x squared term should come first, then the 10x, then the 25. I don't really like to have a negative sign in front of the x squared if I'm trying to factor, so I'm going to factor out -1 from this whole trinomial here. So if I do that, I'll have negative 3ax, and I'll change all the signs here. And now I can factor that trinomial because I know I can put x here and x here, and I want two numbers that multiply together to give me 25 and add up to -10, and that's going to be -5 and -5. So that is the complete factorization of that problem. Okay, I want to find a common denominator and add these fractions together. I do not have an equation here. This is just an expression, so I can't cancel the fractions. All I can do is get a common denominator, add them, add the numerators, and leave the denominator as the common denominator, and just simplify it as much as I can. So I know that I could rewrite this denominator as x, and then plus 3 minus 2 will give me the -6 for the product, 3 times -2, and add up to +1 for that. 3 plus minus 2 is 1, so that's good. I have a factor of x minus 2 here. I have a factor of x plus 3 here, so my common denominator is going to be, will just be x plus 3 times x minus 2. So I need that to be my common denominator. So this first fraction doesn't have the x plus 3 in the denominator. So I'm going to have to multiply the top and the bottom of this fraction by x plus 3. And then this last fraction doesn't have the x minus 2 in the denominator. So I'm going to have to multiply that by x minus 2 over x minus 2. All right, so now I'm just going to write everything as one big giant fraction. So the first term here is 2 times x plus 3, and then minus 2x minus 1. And remember, when you have a minus sign in front of a fraction, that's going to have to be distributed to all of the terms in the numerator, whatever those happen to be. So I'm going to use parentheses around that numerator so that that minus sign gets distributed in a little while. And then minus 2x times x minus 2. That's all over the common denominator of x plus 3 times x minus 2. Now I'm going to simplify that numerator by using the distributive property. So 2x plus 6 minus 2x, and then this minus sign is in front of the parentheses, so it has to be distributed to here and here. So minus -1 is +1, and then minus 2x squared, and then minus 2x times -2, which is positive 4x. And that's all over x plus 3 times x minus 2. Now I'm just going to add my like terms. I have -2x squared. Then I have 2x minus 2x, so those are gone. And then I have a 4x here. And then I have 6 plus 1, which is 7. And then my denominator is still x plus 3 times x minus 2. And I could check to see if that numerator is factorable, and it is not, so that's all I can do here. Okay, we want to evaluate this expression for a as -2 and x equals -3. Before I even put anything in for a to the 0 and x to the 0, I know that those are going to equal 1. So I'm just going to go ahead and say that's a 1 minus a times 1 times x squared minus a
minus 1 over negative 2 to the negative 2 power, which is 1 minus a times 1 is just a, so I can leave that way, and then x squared minus a, 1 over negative 2 to the negative 2 power. Now I'll go ahead and plug in negative 2 for all the a's and negative 3 for all the x's. So 1 minus negative 2 times negative 3 squared. Make sure to put that negative 3 in parentheses with the square outside, minus negative 2, and then minus 1 over negative 2 to the negative 2 power. Remember that negative exponent tells me that I need to take the reciprocal of the base, and that can also mean taking that base and bringing it up to the numerator. So it's still a negative 2 because the negative is still there. It just sits there. It doesn't have anything to do with the exponent. And then the exponent becomes positive 2 because I moved it from the denominator to the numerator. Now, I've got 1 minus negative 2 times whatever is in this parentheses. I cannot add 1 minus negative 2 first. That is not the order of operations. If you remember, parentheses come first, then exponents, then multiplication and division, then addition and subtraction. So I cannot add the 1 and the 2 here. So don't try to do that. Just leave it alone. So negative 2 times whatever's in parentheses. So negative 3 squared, when the negative 3 is in the parentheses and the square is outside, that means negative 3 times negative 3, which is 9, positive 9. And then minus negative 2 is positive 2. And then I'm subtracting a negative. So that is going to be adding a positive, which is 4. 2 squared is 4. Now I am going to multiply that negative 2 by the stuff in the parentheses, which is 11. And then I have 4. I'm still on multiplication now. I haven't gotten to addition and subtraction yet. So 1 minus negative 2 times 11 is negative 22. And then plus 4. Now I can do my addition and subtraction. 1 minus negative 22 is 1 plus 22 plus 4, and that all adds up to 27. All right, x plus 3 quantity cubed. This means I have to multiply x plus 3 3 times together. So the way to do this is to just do 2 of them at a time. Just do these 2 first and leave the other x plus 3 over here. So I'm going to FOIL this out. X times x is x squared. X times 3 is 3x. Don't forget to put a plus sign between them. They're all plus signs here. Now 3 times x is another 3x plus 9. All right, so these are the 2 things that need to be multiplied together now, but first I'm going to simplify that second set of parentheses. So the x plus 3 is right here. I'm going to multiply that by what's over here. I can add the 3x and 3x to get 6x. So x squared plus 6x plus 9. Now I have to do the multiplication again. So I'm going to multiply the x by this, and this, making sure to put a plus sign every time. So x times x squared is x cubed plus x times 6x is 6x squared plus x times 9 is 9x. Moving on to the 3. So I did all those. Now I'm going to do the 3. 3 times x squared plus 3x squared. 3 times 6x, so plus 18x. 3 times 9, so plus 27. And now I'm going to add my like terms. X cubed is the only one like it. 6x squared and 3x squared adds up to 9x squared. Then I've got a 9x and an 18x. That adds up to 27x. And then I just have a 27 at the end. And that's it. Okay, we want to solve for x. That means we want to isolate x. And it's very hard to do when you have fractions. So since this is an equation, we can multiply both sides of the equation by a number that will cancel the fractions. It will make all those denominators cancel out. and that number will be the least common multiple of the denominators. 3 and 5, the least common multiple for 3 and 5 is 15. So I'm just going to go through and multiply both sides of the equation by 15. I'm going to multiply this fraction by 15. I'm going to multiply this fraction by 15. Notice I am not multiplying by 15 over 15. I'm just multiplying by 15. Okay, I'm not getting a common denominator. That's what I would be doing if I were getting a common denominator. I'm not doing that. I am multiplying both sides of an equation by a number, which is acceptable to do anytime you want to. So I'm multiplying this by 15, I'm multiplying this by 15, and I'm multiplying the 2 also by 15, everything, both sides of the equation. When I do this, I will cancel the denominators. 15 and the 3, a factor of 3 has canceled, so I'm left with a factor of 5. Here, a factor of 5 is canceled, so I'm left with a 3. On the right side, nothing cancels because there's no denominator. So now I just need to go back and multiply. The 5 is going to be multiplied by 3 minus 2x. So that's 5 times 3 is 15, minus 5 times 2x is 10x, then plus 3 times x is 3x, and 2 times 15 is 30. Now I'm going to add my like terms. So negative 10x plus 3x is negative 7x. So 15 minus 7x equals 30. I'm going to subtract 15 on both sides so I can get x by itself. So I'll have negative 7x equals 15. Divide both sides by negative 7 to get x by itself. And I will have x equals negative 15 sevenths. All right, I want to solve for x. That means get x by itself. The first thing I'm going to do is go through and change everything that's been raised to the 0 power to a 1. So I've got a 3x, I've got a 2. 6 to the 0 power is 1, so I'm just going to write minus 1. Minus 9x equals 5 times x to the 0. X to the 0 is 1, so that's 5 times 1. Minus the absolute value of negative 6 minus 6 minus 2 times x minus 4 to the 0 is 1. All right, I've done all those ones and they're done. I'm going to go back now and do my parentheses. So 3x times, in parentheses, I have 2 minus 1. 2 minus 1 is 1. Minus 9x, and then 5 times 1 here is just 5. Minus, now I have negative 6 minus 6 inside the absolute value sign. Negative 6 minus 6 is negative 12. I have not gotten rid of the absolute value sign. I've just added the things inside. So negative 6 minus 6 is negative 12. And then over here, I can't do anything to the things in the parentheses because they're not like terms. So I'm just going to leave that the way it is for now because now I'm going to go back and do my multiplication. 3x times 1 is 3x. And then you've got minus 9x. And then you have a 5 minus the absolute value of negative 12 is 12. So 12. And then I'm going to use the distributive property on this last parentheses here. So minus 2 times x, and then negative 2 times negative 1 is positive 2. Now I'm going to add my like terms. 3x minus 9x is negative 6x. 5 minus 12 is negative 7, plus 2 is negative 5. And I still have a minus 2x there. Now I'm going to add 2x on both sides. And I'm going to have negative 4x equals negative 5. I'm going to divide by negative 4. And I have x equals 5 fourths. Now I'm going to use factoring to solve for x. The only way to use factoring to solve is to use the zero factor theorem. And the zero factor theorem only works when you have something that equals 0, which means I need to get everything on one side of the equation and have 0 on the other side. So I'm going to subtract 12 and add x squared on both sides. So minus 12 plus x squared. And so on the left side, I'm going to have x squared minus 4x minus 12. And on the right side, I will have 0. Now I'm going to factor the trinomial. So x goes here, x goes here. I'm looking for two numbers that multiply together to give me negative 12 and add up to negative 4. That is going to be negative 6 and positive 2. Now I know that x minus 6 times x plus 2 equals 0, which means that x minus 6 must be 0 or x plus 2 must be 0. That's the only way you can multiply two things to get 0 is if one of them is 0. Therefore, x minus 6 is 0, so that must mean that x is equal to 6. X plus 2 is 0, so x must be negative 2. So those are the two solutions to this quadratic equation. Here's another one that I want to solve by factoring. This one already has everything on one side with 0 on the other side. This is a difference of squares. 4x squared can be written as 2x squared, and 9 can be written as 3 squared. So now I have something squared minus something squared. That equals the first thing plus the second thing times the first thing minus the second thing. And now I know, since those two things multiply together give me 0, one of them must be 0. So either this is 0 or this is 0. Subtract 3 on both sides. 2x equals negative 3. Divide by 2 on both sides. X is negative 3 halves. Over here, add 3 on both sides. 2x equals 3. Divide by 2, x equals 3 halves. So the possibilities are negative 3 halves and positive 3 halves. I want to solve this system of equations by elimination or substitution. I'm going to use elimination. So I'm going to multiply this first equation through by negative 3 because I can see that x and 3x would be easy to cancel if I just multiply that x by negative 3, and then I'll have negative 3 plus positive 3 will be 0, and that makes the x's cancel. So I'm going to multiply the whole first equation through by negative 3. Multiplying by 3 on both sides of an equation, or in this case negative 3, is allowed. So I'm going to do that. Negative 3 times x is negative 3x. Negative 3 times 3y is minus 9y. Negative 3 times negative 3 is 9. This second equation, I'm not going to do anything to it. I'm going to leave it the way it is. Now I'm going to add the two equations together. Negative 3x plus 3x is 0, so that's gone. Negative 9y minus 5y is negative 14y. And 9 plus 19 is 28. So if I divide both sides by negative 14, I can get y by itself, and I'll get y equals negative 2. Now that I know what y is, I can go back and plug negative 2 into either equation and solve for x. I'm going to plug it into the first equation. So the first equation is x plus 3y. Y is negative 2, so I'm going to put that there, and that's supposed to equal negative 3. X minus 6 is equal to negative 3. Add 6 on both sides, and you will get x equals 3. So my solution to this system of equations is 3, negative 2.